Friends, welcome to this lesson on serial transmission modes. Data communication between a computer and a peripheral can be done in two ways, the serial transmission and the parallel transmission. The serial transmission uses a common data path for the different bits that have to be transmitted. The bits are transmitted one after the other, and that is why the name serial transmission. What is the other method that is used? If each bit is allocated a dedicated path, then we get what is known as the parallel transmission mode. If 8 bits are to be transmitted, then 8 transmission lines are required in parallel transmission mode. The parallel transmission is used when the computer and the peripheral are close together. The serial transmission is used for longer transmission distances, say if the separation is more than 5 meters. The reason is serial transmission requires fewer lines. So if the same data path is used for transmitting the different bits, then how is the receiver going to identify the beginning and end of a bit? How is the receiver going to identify the beginning and end of a byte? So for this bit and byte identification, special timing signals are added with the data and transmitted along with the data. Such timing signals are known as the synchronizing signals. Two different methods are used to add these synchronizing signals. Accordingly, the serial transmission is known as synchronous transmission and asynchronous transmission.
When large volume of data is to be transmitted, synchronous transmission is used. The entire data is treated as a block. Synchronizing signals are just added once before the block and transmitted at a fixed rate over the line. This is known as synchronous transmission. The term synchronous means the number of characters transmitted per second is uniform over the entire transmission period. Framing overhead for synchronous transmission is much smaller and therefore it is much efficient. It is used for high-speed data transfer. However, it requires complex circuitry at the receiver for clock and data recovery. Asynchronous transmission adds timing signals to each character of data. A start bit is added at the beginning. A stop bit is added at the end. A low-level signal is used for start bit. A high-level signal is used for stop bit. This process of adding start and stop bits to a character is known as framing. The falling edge of the start bit is the timing reference. The 1 level of the stop bit and the 0 level of the start bit ensures a high to low transition for every character. A parity bit is also added to the data bits just before the stop bit. Thus, every character contains a start bit, data bits, parity bit, and a stop bit. The asynchronous transmission uses simple circuitry. It is used for low-speed data transmission up to a speed of 20 kilobits per second.
Now let us study the terms and standards associated with serial transmission.
The number of bits transmitted per second is called bit rate. The bit rate is also known as baud rate. if the direction of data flow through a serial line never changes, that is, if it is a one-way transmission, then it is called simplex transmission. In duplex transmission, data can flow in both directions. However, if the transmission goes one way at a time, it is called half duplex. If data flows both ways simultaneously, then it is full duplex system. The walkie-talkie wireless communication system is an example of half duplex system. A telephone conversation between two users is an example of full duplex system. On the transmission line, the signal could be transmitted by two ways: as a current pulse or as a voltage pulse. The current pulse method is known as current loop. For a logical 1 level, current flows through the line, and for a logical 0 level, no current flows. There are two standards for the current loop: 20 milliamps loop, 60 milliamps loop. The figures 20 milliamps and 60 milliamps specify the amount of current flow for one level. A current loop reduces noise pickups and so is suitable for long-distance transmission. When data is transmitted as voltage, the standard used is RS-232C. A one-level signal is transmitted as -12 volts. A zero-level signal is transmitted as +12 volts. A device called line driver does this voltage level shifting at the transmitter end. A line receiver does the reverse shifting at the receiver. This level shifting is done to overcome losses and for better noise performance.
We have just learned the details about serial communication systems. One of the most common applications of serial transmission would be communication between computers. Imagine two offices situated at two corners of a city. If the computers in these offices want to communicate, how are we going to connect them? Are we going to lay a dedicated RS-232C cable between them? A ready-made and quick solution would be to use the telephone connection between these two offices. The advantage is the telephone cables are already laid out. However, there is a problem. The telephone cables support only analog signals. They will not readily support the digital signal. Therefore, the digital data has to be translated into audio frequency analog signals.
A device called modem, modulator and demodulator does this signal translation. A sending modem converts digital data into audio frequency analog format. A receiving modem converts audio signal back to digital data. Modems often use a technique called frequency shift keying for this conversion. This technique converts a one-level signal into an audio signal at 1200 Hz and zero level into audio signal at 2200 Hz. The calling computer simply dials the receiving one, and a link is thus established whenever there is need to send data. An exclusive RS-232C line or a telephone line with modems carry the signal between places. Modem communicates with the computer using control signals.
The microprocessor 8085 has facilities to handle serial transmission. Now we are going to learn about the 8085's facility for serial transmission.
The 8085 has a serial output data pin SOD and a serial input data pin SID. They can be used for software-controlled serial data transfer. The SIM and RIM instructions are used for this purpose. A 0 or 1 can be transferred out through SOD pin by executing the SIM instruction. The first step is to load the data bit into the accumulator. Where D7 is the serial data, D6 enables serial output operation. The single bit data to be transmitted is placed at the D7th bit. A 1 at D6 bit enables the SIM instruction. To send a 1 through the SOD pin, the data byte pattern would be 1 1 0 0 0 0 0 0, that is COH. The program segment sends out the 1 bit through the SOD pin. The program segment sends out a 0 bit through the SOD pin. The SID pin can be used to receive serial data. The RIM instruction is used for this purpose. When the RIM instruction is executed once, the single bit data available at the SID pin is brought into the accumulator as the D7th bit. All other bits are made 0. Thus, the SID and SOD pins may be used to transmit data in and out of the microcomputer. The framing of the data for synchronous or asynchronous format can be done using software.
A better approach is to use a dedicated device to handle the serial communication. The Intel 8251 is a serial communication controller which is to be used with the 8085 CPU. The 8251 is fully programmable. It supports simultaneous transmission and reception. It can be programmed for asynchronous and synchronous operation. The 8251 has provisions for interfacing with modem. Therefore, 8251 is known as Universal Synchronous Asynchronous Receiver Transmit Module. Let us move over to the graphics to learn the details about 8251.
The 4 functional blocks of the device are the receiver section, transmitter section, modem control section, and microprocessor interface section. The input register of the receiver section gets the serial data input. The data is clocked into the input register using the receiver clock. With every falling edge of the receiver clock, a new bit is entered into the input register. It receives the data bits along with framing bits. They are transferred to the receiver buffer register. The buffer stores the data in parallel format. The RX ready is raised to indicate the buffer has a character ready for the CPU. Along with these steps for receiving data, the 8251 is capable of simultaneously transmitting data. The transmitter buffer register accepts parallel data from the processor. The data is transferred to the output register. The TX ready is raised after each data transfer from buffer register into output register. The TX ready may be used to interrupt the CPU for a new character. Framing bits are added. The assembled character is sent out through TXD bit by bit. Every falling edge of the transmitter clock sends out one bit out of the output register. After all the bits are transferred, the transmitter empty, TXE, is raised to indicate it is ready to receive one more character. The modem takes care of interfacing with the telephone line. Therefore, it is called the data communication equipment. The microcomputer is the data source. Therefore, it is known as the data terminal equipment. The 8251 is a part of the microcomputer. IC 8251 has all the control signals necessary to interface a modem with a computer. The 8 data lines are connected to the data bus of the CPU. The internal registers of the device can be memory mapped or I/O mapped. The read bar and write bar lines enable the CPU to read and write into these registers. In this example, the device is I/O mapped. Therefore, the read bar and write bar are connected to the IOR and IOW signals of the bus. The CD bar line enables the control or data register. The CS bar is connected to the external address decoder.
The device 8251 is a programmable device. It has two 8-bit registers to store the mode word and the command word. These two registers reside at the same address. They are accessed through the write operation. The mode word sets the different parameters for serial transmission. The contents of the command word register are used to enable and disable the transmitter and receiver sections. Friends, now let us see a demonstration of serial communication between a personal computer and a microprocessor trainer kit. The serial port of this personal computer is connected with the serial port of this trainer kit. The trainer kit has an 8251 to implement serial communication. The trainer kit is set for serial transmission through this dip switch. The message serial appears on the display. Any program to be run on a microprocessor trainer kit can be conveniently entered and edited on the personal computer. Any text editor can be used for this purpose. The advantage is the program can be in mnemonics and it can be assembled later into a machine code. The file is assembled using cross-assembler to produce the object code. The object code file is converted into hex code file using the linker. The hex code file has to be transferred to the kit. For this, the serial communication software XT852 is used. For running a program, we need to give the starting address on the RAM. So now TTTI is displayed on the kit. Thus, the serial communication is established.
The device has a control register which can store 2 bytes, the mode word and the command word. The mode word sets up the basic parameters needed for transmission, such as synchronous or asynchronous operation, baud rate, number of stop bits, and type of parity. D7 and D6 represent the number of stop bits. When D7 is 0 and D6 is 0, it is invalid. 01 indicates 1 stop bit. 10 indicates 1.5 stop bits. 11 indicates 2 stop bits. D4 enables the parity. D5 determines the type of parity. When D5 is 0 and D4 is 0, then no parity. 01 represents odd parity. 11 represents even parity. D3 and D2 represent the character length. When D3 is 0 and D2 is 0, then it means 5 bits character length. 01 means 6 bits. 10 means 7 bits. 11 means 8 bits. D1 and D0 represent the baud rate factor, the relation between the baud rate and the transmitter-receiver clock. When 8251 is used in synchronous mode, D1 is made 0 and D0 is made 0. Other bits option determines the baud rate factor for asynchronous mode. 01 indicates that the clock is same as the baud rate. 10 indicates that the clock is 16 times the baud rate. 11 indicates that the clock is 64 times the baud rate. Let us see an example to set the mode word for asynchronous mode. 1200 baud, keeping the baud rate factor 64. The clock frequency is equal to 76.8 kHz. 8-bit character and 2-bit stop bit. Odd parity. The mode word becomes 1101 1111, that is DFH. Assume the data register at the address 40H and the control register at 41H. This program segment will load the mode word into the control word register. The basic parameters have been set using the mode word. The actual operation is controlled by the command word. Functions such as enabling the transmission and reception, error resetting, and modem control are provided by the command word. The device has a single control register. After reset, the first write operation in this control register is treated as mode word, and the subsequent write operations will be treated as command word. That is, the command word can be changed at any time during the operation. However, to change the mode word, resetting of the device is needed. Resetting can be done using the reset pin or through the command word itself. The D7 bit is used in synchronous mode. It enables the receiver to look for the synchronizing data. The D6 bit is used as the internal reset. A high level resets the device so that a new mode word can be entered. The D5 bit is used for modem control. The D4 bit resets the error flags. It resets the parity, overrun and framing error flags. The D3 bit makes the transmitter send continuous break characters. The D2 bit enables the receiver. The D1 bit controls the data terminal ready pin. The D0 bit enables the transmitter. In order to set the device for transmission, the command word would be 0001 0001, that is 11H. The program segment will load the command word into the control register.
When the mode word and command word are written, the device starts sending and receiving data. In order to know the status of the transmission and reception process, a register called the status register is to be read. Now let us understand the format and meaning of the status word stored by the status register.
The D7 bit indicates the status of the modem. The D6 bit indicates the detection of synchronizing data. It is used in synchronous mode operation. The D5 indicates that framing error has occurred, that is, a valid stop bit has not been detected. The D4 indicates overrun error, that is, a new character has arrived, but still the old one was not read in. The D3 indicates parity error. D2 assumes the level of the transmitter empty pin. D1 assumes level of receiver ready pin. D0 takes level of transmitter ready pin. The status register is used to check the current activity of the IC. The address of the register is same as the mode set and command register. However, it is accessed by a read operation. Suppose the CPU wants to send an 8-bit data to 8251 for serial transmission. First, the CPU checks whether the 8251 is ready. It does the checking by reading the D0 bit of the status word. The program checks the status word continuously until it finds D0 high. Then it sends the data to the data register of 8251. It is to be noted that the address of the status word register is 41H and the address of the data register is 40H.
Now we will review what we have learnt in this lesson. The serial transmission is the preferred method for fairly long distance transmission. High-speed transmission systems use synchronous mode. Asynchronous mode is essentially a low-speed mode. The RS-232C is a widely used serial transmission standard. The modems enable telephone lines to be used for interconnection. The 8251 is a powerful serial communication interface device. It can transmit and simultaneously receive data up to 9.6 kilobaud. It can implement synchronous and asynchronous format. It also implements modem control signals. It has built-in error detection facility. Thus, using serial communication, a microcomputer can exchange data with another computer or with a remote terminal. It can be implemented with a dedicated RS-232C line or using existing telephone lines. So, until we meet again, goodbye.